wants to know if it's 1 to 1. And it's a graph that looks like this. Is that 1 to 1? No, why not?
It crosses the vertical axis 1 to 1.
So, yes, I agree.
I
But
just plotted the points and like there was 0 was an X like 3 times.
okay.
I don't know if that makes sense.
It does, and I think you mean 0 was a Y. though,
Yeah,
because
0
it
was a
crosses-
Y.
And so, yeah, because it was repeated, no, it's not 1. Another thing that they kind of talk about is like to tell if it's a function, it has to pass the vertical line test. And then to tell if it's 1 to 1, you can do like the horizontal line test, which is like if it crosses, like because my pen, like it would hit my pen twice at this point, you know, so it wouldn't work to be 1 to 1. Does that make sense? So no, not. Okay. It says f of x equals 9 minus x over 6, and we want to know f inverse of x. How do we find the inverse? Yeah, switch all the x's to y's. And so this is like saying y equals that. So we're gonna put x equals 9 minus y over 6, and then we're gonna solve for y, okay? So what's the first step in solving for y? Yeah, moving the denominator how? Yeah, multiply by 6. So you're gonna multiply this side by 6, this side by 6. And those are gonna cancel. So we get 6x equals 9 minus y. And now what?
Move the y's over.
Okay, so we could, do you wanna add it over here or subtract 9? Add it, okay. So we get y plus 6x equals 9. And then now what? Yes. So y equals 9 minus 6x. Which is answer choice B. Okay. Okay, number 14. Same thing, but just a little more. Says f of x equals x plus 4 over x plus 9, right? So we want to know f inverse x again. And so to do that, we're just going to replace the x's with y's and then put x over here. So we say x equals y plus 4 over y plus 9. Alright, how would we solve for y in this case? Do they just cancel? You can do the, how so? Y plus 9? Yeah, the whole goal here is to get rid of the denominator. The y's don't just cancel. Never do that. So do y plus 9 times y plus 9. So these two go away. We're left with y plus 9 times x equals y plus 4. Okay? And now what?
Oh, you got it.
so it wants to know some of the properties about this graph. Like, what is the range and like is it upward or downward facing? So first of all, with upward or downward facing, which way is it? Does it go this way or this way? Down? Why is it down? Yeah, because that -4, right? So this guy determines, this guy says it's downward. Okay, and then it wants to know the range. Okay, so we know that -6 right here, because it's outside of everything, it like is what determines how it moves up and down, okay? So we know it's downward facing with its like point, its most point at -6. So if we were to graph that out, kind of, it would be like, so here's -6, and we said it's downward facing. So it's like down like that. So is that a maximum or a minimum?
Max.
That's a maximum, yeah. And so what is its range? 0? So 0's up here. Yeah, starting at infinity. So you want to start at the lowest point. Remember, range is your y. So you want to start at the absolute lowest point and then go up. So it's going to be from -infinity. Remember, not including it. And then do we include -6? Yes, we do, because it hits that -6. And that is answer choice A. Any questions?
Why can't it be -6 and then?
To -infinity?
Yeah.
Or
Can it
plus? So just the way like these things work, like these they're not inequalities, but to find it, you always start with your lowest point and then go up. So you're gonna start with like whatever is the smallest and then go up to the highest.
Okay.
So if it went from like let's say it was like that, like upward facing,
Mhm.
then we would start at -6 and say it goes to infinity.
Question.
Uh-huh.
When would you not include, like, what instance would you need for you to not include the -6?
So if it had a denominator, that's whenever you, because the denominator can never be equal to 0.
Mhm.
So like if we wanted to know, like when doesn't this one exist, we would say from